Section 7.2, adding and subtracting rational expressions. So in 7.1 we looked at multiplying and dividing these rational expressions, and we remembered how to do, or we used the rules of regular fractions to kind of develop our rules for these rational expressions. We're going to do the same thing now that we're adding and subtracting. So let's first review the idea of just adding and subtracting fractions, basic regular fractions. So in order to do this, we need a common denominator, and then we can combine. We don't multiply straight across the top and bottom like we do when we're multiplying fractions. Obviously we have a different process here. So for example, the problem 2/7 plus 4/7, since we have a common denominator of 7, we can go ahead and just add across our numerators, 2 plus 4 giving us 6, and then we keep that common denominator 7. So that would be equivalent to 6/7. And then when we don't have a common denominator, in this case we have 3 and 4 different denominators, we have to find an LCD, a lowest common denominator. So the smallest number that both 3 and 4 will go into. Okay? So you want to think of multiples of 3, multiples of 4, and the smallest one that they both have in common is going to be 12. Okay? So that will be our least common denominator. So if we need to multiply the 3 by 4 to get 12, we have to do the same to the numerator to keep this fraction equivalent to 2/3. And then 1/4, if we need to multiply the 4 by 3 to get our lowest common denominator of 12, we need to do the same to our numerator, 1, in order to keep an equivalent fraction. So this, now we can convert our fractions. 2/3 when we multiply by 4 and 4 is going to become 8/12. And 1/4 when we multiply by 3 and 3 is going to become 3/12. When we get to this point, we now can go ahead and combine the fractions since we have our common denominator. So we go ahead and subtract across the numerators. 8 minus 3 gives us 5, and we keep that common denominator of 12. So our answer would be 5/12. Okay? So that's the idea, little idea of reviewing fractions. We're going to use these ideas to help us now when we're adding and subtracting these fractions that are rational expressions. Okay, these crazy looking fractions. So first we'll start with rational expressions that have the same denominator, since that will be a little bit easier than when they don't. So we have 7 over 2r squared minus 11 over 2r squared. So when it's set up like this for you, you already have a common denominator. We can go ahead and subtract across our numerators, 7 minus 11, and we keep that common denominator once we have it. So we know we're going to have something over 2r squared, the common denominator. 7 minus 11, if we subtract across the top, that should give you a -4. So this is going to be equivalent to saying -4 over 2r squared. But now we want to consider what we did in 7.1, where we were simplifying these rational expressions. We have a common factor, the numerator 4 and the denominator with the 2, those both share a common factor of 2, okay, because 2 can go into both. So 2 goes into 4 twice, whereas 2 goes into 2 once. So 4 over 2 will reduce to 2 over 1. Or, since we have an r squared down below already, we can just write this as -2 over r squared. We don't need to put the 1 out in front of the r. Okay. And there's no more common factors now. There's no r's up top. There's nothing with a common factor of 2 down below. So that's all we can do with that problem. We're done there. Our next example, okay, we have ourselves a common denominator, so we can go ahead and combine our fractions, since we do have the common denominator, x squared plus 2x minus 8. Okay. So I'm going to come over here and do that. Since we have the common denominator, we can go ahead and add across our numerators. 4 plus x, or in other words, we could rearrange that, write it as x plus 4, over the common denominator, which is x squared plus 2x minus 8. Okay. well, we get to this point, you don't want to start trying to cancel x's out or even think about the 4 and 2 or the 4 and 8 as having common factors. Remember, when we have something like this, we have to factor the top and bottom before we can see if we have common factors. So x plus 4, since it won't factor, we have somewhat of a implied parentheses around the top, and then we have to factor this denominator to see what we get. Okay. So let's do this. Factor to check fraction for common. For common factors, I guess. Okay. After we factor the fraction, if we have any common factors, then, well, we're going to be able to divide those out. Alright, so x plus 4, well, nothing we really can do with that. That's going to stay in x plus 4. And if you want, put the parenthesis around it to remind yourself you can't do anything with that unless we have another x plus 4 down below. Factoring the bottom expression, x squared plus 2x minus 8. To factor that, we want to look for two numbers that multiply to give us negative 8, add to give us positive 2. Those numbers are going to be a positive 4 and a negative 2. So it factors into x plus 4 and x minus 2. Okay. So now that it's in factored form, we do see we have a common factor. The x plus 4 is common to the numerator and the denominator, so we can divide that out. But now we don't really have anything in the numerator, so we do actually have to write the 1 there. You don't have to write the 1 out front of the x minus 2 because we still have something down there. We have the x minus 2. But because we have nothing left in the numerator, we need something to hold a place in the numerator. So we put that 1 up top. And now there's nothing else we can do with this fraction. That would be our final answer. 1 over x minus 2. Okay. So that's fractions when we have, or rational expressions when we have a common denominator. Now we're going to look at when we don't have a common denominator, and in order to do that, we have to be good at finding the least common denominator, or LCD. Okay, I use that abbreviation up top. That's what I'm going to use now from now on when I want to find a common denominator, an LCD, because we want to find the smallest denominator that's common to them all. So first of all, to find an LCD of just different expressions, because these are going to be the expressions that are in our denominators that we have to find an LCD for. We do this by breaking the expressions down into, their different factors. So we can take this, our two expressions here, 5xy squared and 5x cubed y. So 5xy squared and 2x cubed y. And we want to go ahead and break this down now. So 5xy squared we can rewrite as 5 times an x times 2 y's, because y squared is 2 factors of y. And 2x cubed y is going to be equivalent to 2 times 3 factors of x times a single factor of y. Okay? And at this point, what we want to look for is essentially what's missing from each list that the other list has. Okay? To find a common denominator, we need to find something that both denominators can multiply into. So we want to make these two lists essentially make a match. So you can start by looking at the 5xy, 5 times x times y. What factors does this bottom list have that the top list doesn't? Okay, so in looking at it, okay, we have a factor of a 2 that our top list doesn't have. So I'm going to write this in parentheses, times a 2. Also, we have two factors of y, and down below there's only one, so we don't need any more y's, but we only have one factor of x, whereas down below we had three factors of x. So we need to add in, or not add in, but multiply in an additional two factors of x. Okay, or in other words, x squared. Because that's going to make that x, and x be an x cubed. Technically right here, if we re-multiplied all this out, that would give us our LCD. But in order to make sure lists match, you can do it the other way as well. What does this list miss? What is this list missing that the top list has? So it's missing a factor of 5. It already has the 3 x's, but it only has one factor of y, so it needs an additional factor of y in order to match the 2 up top. Okay. So now we've done what we set out to do, which is make the two lists match. Not math. Match each other. Now they match, so multiplying them back out is going to be our LCD. So 5 times 2, or 2 times 5, is going to give us 10. And then in each list we now have 3 factors of x, so x to the third, or x cubed, and 2 factors of y, so y squared. So that's our LCD, or, well, in this case, our LCM, our least common multiple, but that would be the denominator we'd want to turn our fractions into if these were the two bottoms, if these were the two denominators and fractions we were adding or subtracting. Okay. So let's do that with a couple more examples, make sure we're good with that before we actually start adding and subtracting the fractions. Let's say we were asked to find the least common denominator of k and k minus 3. Alright, so we can come with our lists, and we kind of want to factor down the expressions like we did up here, but well, with k there's nothing to factor, it's just a k. And then with k minus 3, again there's nothing to factor, there's no GCF between k and minus 3, so all we really can write that is, again, is k minus 3. So in this instance, both of our expressions can't be factored. So when that's the case, we just combine our two factors. Okay? We can think of k as its own separate factor, and we can think of k minus 3 as its own separate factor. So what is the k's list missing? Well, it's missing a k minus 3. And what is the k minus 3 list missing? Well, it's missing a single k. So we kind of just throw the two factors together, k and k minus 3. And you want to keep it in parentheses, you wouldn't want to distribute, because it makes it easier for us to keep it in this factored form. Okay, so technically you could say the lowest common denominator would be k squared minus 3k, but you don't want to write it that way. You want to keep it factored how we have it. Okay. Last example, what about finding the LCD of m squared plus 5m plus 6, another expression m squared plus 4m plus 4, and a third expression 2m plus 6. Well, when we start a problem like this, we definitely want to factor each to begin. So m squared plus 5m plus 6. We want to go ahead and factor that. M squared plus 4m plus 4. We want to go ahead and factor that. And then 2m plus 6. We want to factor that. So m squared plus 5m plus 6, no number out in front of the m squared. So this is the easier one to factor. Two numbers that multiply to give us 6, add to give us 5. Those numbers are going to be positive 2 and positive 3. So that should factor into x plus 2 parenthesis and an x plus 3. We want to factor this second expression the same way. two numbers that multiply to give us 4, but also add to give us 4. No, sorry, I don't know why I wrote x's here. Those should have been m's. Okay, pretend these x's here are m's. M plus 3, m plus 2. Here, two numbers multiplied to give us 4 that also add to give us 4 are going to be an m plus 2 and another m plus 2. 2 times 2 is 4, 2 plus 2 gives you 4. So we would factor that way. And then lastly, we don't have an m squared out front, so we can't factor this the same way, but we can pull out a GCF. Both 2m and 6 have a common factor of 2. So 2 times m would get us back to 2m, and then 2 times a positive 3 would get us back to the positive 6 there. So that's how the third expression would factor. So just as we did up above in the first two examples of finding the LCD, we need to make our lists match. Okay, what factors are each list missing that the other lists contain? So this list has an m plus 2 and an m plus 3. Down below in the middle list, there's 2 factors of m plus 2. So this list needs an additional m plus 2. Okay. So now it has everything the middle list has. And then looking at the bottom list, it already has an m plus 3, but it doesn't have that factor of just a 2. So we need to include that in as well. So again, since I'm including extra things in, I like to throw them in parentheses. Again, that would tell us our LCD, but we can try to make all 3 lists match in order to really make sure we have it correct. What is this list missing? It doesn't have an m plus 3 factor. So there's 1 up above, there's the 1 down below. So at most, each list only has 1 factor of m plus 3. So we just take 1 factor of m plus 3. And it's also missing the factor of a 2. Okay. And now our bottom list has the 2 already, has the m plus 3 factor that both of these now have, but it doesn't have the 2 factors of m plus 2. So we want to include that in its list. Okay. So now our 3 lists match each other. Gosh, I keep writing that. The lists now match, not math. Alright. So we can go ahead and write out our LCD. Well, taking any of the 3 lists, since they're all the same. Well, we have a 2. Usually we put any numbers out front. We have 2 factors of m plus 2. So we would want to write that as m plus 2 to the 2nd power. Although you could write it as m plus 2 and another m plus 2. You don't have to write it squared like this. And then there's a single factor of m plus 3. So we kind of want to attach them all together. And that right there would be your LCD. Okay. So the skill we just practiced in these last 3 examples are what's going to help us on the next page of the notes, which is actually adding and subtracting the fractions, which will require us to find an LCD. So let's take a look at that now. So we have rational expressions with different denominators now. We already looked at how we handle them when they have the same denominator. Now they get a little trickier, but we just found out how to make them have the common denominator by finding the LCD. So our first example, 5 over 4p plus 3 over 10p, different denominators. We need to come up with a common denominator. So we look at our 2 denominators, 4p and 10p. And we can think about their lists. Well, this one's easy enough, probably not even have to make a list. I guess what is the 4p? Maybe not. You want to think of a number that 4 and 10 can both go into. So if you can easily see that it's going to be 20. 4 and 10, the smallest number they both go into is 20. And they both already have that factor of p. So our LCD is going to be 20p.